Alright, we are back to the mathematics of GIS, and in this part we're gonna look at cross products. So what is cross product? Here we have a definition for cross product. So cross product of two vectors A and B is actually a vector. So cross product of A and B is C, and vector C looks like this. And because cross product is actually a vector, so it can be represented in a figure like this. So if we have vector A and vector B, we can determine the cross product of A and B is C. So vector C is actually perpendicular to vector A and vector B. And we can also determine the length of vector C, which is the cross product of vector A and vector B, using this formula. So in this formula we can see that the length of cross product C is actually equal to the length of vector A multiplied by the length of vector B, then multiplied by sine of the angle between A and B. So let's look at an example, and we want to try to implement it in Python. So here we have example 56. So in this example here, 56 here, we have two vectors A and B. So let's say given vector A is equal to numpy.array, vector A is 1, 0, 0, and similar, we can define vector B is 1, 1, 0, like that. What we need to do is we need to determine the cross product of A and B and determine the length of that cross product vector. So for example, we have here C is a cross product. So cross product can be determined using Numpy. So we can go Numpy and dot cross function. Then we put in A and B. Just by that way we can have the cross product of A and B. Then the norm of C is actually C norm or C length is equal to Numpy dot linear algebra dot norm, and we put C inside here. Then now we can have A, B, C and the length of C. So A is this, B is this, C is looking like this, and the length of C is like this. So this is actually the first method to determine the length of a cross product vector. Okay. We have second way to determine the length of C using this formula. So to determine the length of C by this method, we need to determine the length of A and the length of B, and also the angle between A and B, and just get the product of A and B and the sine of the angle between A and B. So let's try it here with a second method to calculate the length of C. So firstly we need to determine the angle, or firstly we need to determine the length of A. So A length is actually just M and norm of A. B length is actually just norm of B. But the angle, we need to find to determine this angle, we need to come back to this formula. So we need to define the dot product and then divide it by the length of A and B. So dot product, which is dot of A and B, is actually just Numpy dot A and B. Then the angle 3, which is in radian, is actually just we need to import mass as well here. import math. We get math dot a cos of what? Of something over something. Something over something. So above here is just the dot of A and B, and below here it's just a length multiplied by B length. Then we need to convert it into degree. Oh, we don't need to. So now, if we look at this formula here, we want to determine the length of the cross product. We have the length of A and the length of B, and the sign of that. So now, C length is going to be equal to something over something. Something above here, which is A length multiplied by B length. And down here we got numpy dot sine of phi radian. Then we get the C length. Numpy have no attribute called norm. Actually, yeah. So in order to calculate the norm of the vector, I forget that we need to use norm inside NINAC. So it needs to be nin algebra like that, and inside here like that. We run this again, and we have C length is 2. Okay, I think something wrong here. It needs to be 1. So let's see what happened here. Alright, so actually this is not divided here, so this is multiplied here. So number is 1. So we have different ways of calculating the length of a cross product vector, which is using the first way is determine the vector, and then determine the norm of that vector. The second way is determine the dot product between two vector and the angle between two vector, and then we can also determine the length of that cross product vector. But what is actually the length of a cross product vector? So the length of C is a cross product vector A and B is actually the area of the parallelogram spanned by A and B. So that's why we have the value. That's why we have two different ways to calculate the length of C. And that's it for this section. What is cross product and how to calculate the length of the cross product vector.